So today we have the, I'm just still kind of working on the test prompts to make sure I got it all good and stuff. And yeah, I kind of would just like to go over it again.
Okay.
If that's all right. Starting with these ones here. So real quick before we start. So this is the 30-minute session, and then right after this at 11 I have an hour session, I believe.
Right.
No, okay. I'm just trying to make sure.
Yeah. No, you're scheduled for an hour and a half.
Okay.
Feel free to quit any time. I wouldn't bother me.
All right. So this one here, the first one we have is 7x squared minus x equals 0.
Okay.
I just need a little refresher on how to solve these.
Okay. Here's the thing you have to realize. It's a factoring problem.
Yeah, I get that.
The reason it's a factoring problem is because if we can separate this thing into two things that are multiplied together and they're equal to 0, then we'll know that each thing can be equal to 0. So, as a factoring, there is a priority that you use. What's that called?
Greatest common factor?
That's the first thing you always look for. Always. So, is there a greatest common factor?
X.
Okay. Leaving x times what, in other words?
7x. Yeah.
Keep going.
And then 1, negative 1.
Negative 1. Now, at this point, always do your check right now. Multiply, in other words, distribute that x back to those two terms and make sure you get what you started with. Because it's easier to find mistakes at this point than it is when you get to the end of the answer. It's almost impossible to figure out where you made your mistake if you get to the end. So now that I know this is true, I have one thing times another thing equals to 0. Then how do I solve for x?
Do you plug 0 in for x?
Nope.
Would we...
Let's let that equal a. Let's let that equal b. And we have a times b equals 0.
Okay.
That tells me a equals 0 and b equals 0. So you don't plug in 0 for x. What you do is you set that equal to 0 and solve for x. Now, the first one, the answer is x equals 0. But the second one is not. What's the second one x equal to? In other words, there are two answers for x. You always have two answers for x when you're looking at quadratics.
Okay.
How do I solve for b?
Would we have to...
We'd have to solve for x, but what do I do?
Would we...
would
we make this 7x minus 1 equal to 0?
Yes. That's what has to be 0. It's not x. It is the quantity that is multiplying the other quantity. That's what has to be x. So
then we add 1.
Okay.
So we add 1 to both sides and we get 7x equals 0. And or 7x equals 1, sorry. And then we divide by 7, and we have x equals 1 over 7.
Okay, so there's your two solutions. Now, if you add x plus 2 times x minus 3 equals 0, well, you certainly would not plug in 0 for x. What you would do is take the first quantity, x plus 2, let it equal to 0, solve, And then you take the second quantity, x minus, what happened?
What just happened there?
I don't know. My writing board disappeared on me right in the mid drawing.
That's a little weird. But no, I think I get the concept of that.
A Microsoft product. Okay. It just happened in this case that, yes, one of the solutions was x equals 0.
Okay.
Okay. So always there are 5 priorities. First one, you try greatest common factor. Second one, you see if it's dopes. What's dopes stand for?
I don't really remember, and I don't want to guess.
Difference of perfect squares.
Okay.
Okay. Third, you can square root both sides. Sometimes.
Okay.
With certain kinds of functions. Every one of these is factoring. And fourth is your more traditional quadratic factoring, where if you have an x squared term and an x term and a number, then you have to factor it as a 3-term quadratic. And fifth, if none of that works, you got the quadratic formula. So there's your order. Every single problem, you go through this checklist and see, okay, what can I do? Can I do greatest common factor? No, it's not dopes. I can't do square root of both sides. Got to do a standard quadratic factor.
Okay.
Okay. Math is about memorizing methodologies.
Yeah.
It really is. In other words, you need to memorize those 5 things I just wrote up there in order. And then just every equation they give you, just go through them. And you'll find which one to use. So what's the next problem?
The next problem we have is 49x squared minus 16 equals 0.
Notice how this thing's flashing back and forth. All right. Is there a greatest common factor?
It doesn't have one, does it?
No, doesn't. We'll put an X next to that. Is it dopes?
Okay. Difference of perfect squares? Yeah, that one would be it, wouldn't it?
Yes, it is that. Okay, now let's apply it. So this is going to separate into 2 things. Equals 0. That's the whole reason we're doing it. What's the first thing? And
would it be x in the first one?
no, here's what it is.
No.
Well,
I think I remember.
General formula. A minus b squared. There's your 2 perfect squares. Factors into a minus b times a plus b every single time. Okay?
Okay.
So what you have to figure out is what is a and what is b here.
So would a be...
That's a squared, right?
Yeah, so that means it would be 7.
So 7x is a.
7x.
Minus b. What's b?
And 4? Negative 4? Yeah, just negative 4.
4. It actually b is 4 because the negative sign's built into this formula, notice. In other words, the first term is a minus b. So we have written a minus b. Now you don't need to do any work for the next one. It's automatically
the same thing
with a different sign. In other words, it's called the conjugate. What's the conjugate?
It's the direct opposite. Or it's like the same thing.
Read it to me. Tell me what the conjugate is. Not
the conjugate is 7x plus 4.
An expression.
It's 7x plus 4.
That's plus 4. That's what I was looking for. Okay?
Okay.
Yeah, I never ask for meanings of terminology. That's not what I believe is the way to teach math. You teach math by, give me what the thing I'm supposed to write is, not the...
Alrighty.
Okay? All right, let's go on to the next one.
So then would we make the...
Oh, sorry, let's finish this one. Yeah, okay.
yeah. Would we make them both equal to 0, correct?
Mm-hmm.
All right.
I trust your algebra skills are good enough to handle this part.
Yeah, I got that.
I don't think we should waste time doing that part.
Yeah, that makes sense.
In other words, once you get it, once you get the fact that you have to set that equal to 0 and you have to set that equal to 0, and then you just solve for it.
Okay.
Okay? But this is
Sounds good to me.
one stuff here. I don't think we should be spending our time on arithmetic.
No, yeah, we're good now.
Okay, so what else do we got here?
So C, we have 2x squared.
Hold on one second.
2x squared minus 20 equals negative 3x.
Okay,
Now,
first thing to recognize is that we have an x squared term, we have an x term, and we have a number.
that's a quadratic, isn't
The
it?
very first thing you should do is put it into standard quadratic format, which is
So that,
everything on one side, 0 on the other. You don't do that with all of these, but when you see that it's a standard quadratic, that's what you do.
so we'd have to move the negative 3 to the other side.
Okay, so that gives me this. And I put it in its proper position in between, and that leaves 0 over there. Now, let's go through our checklist. Is there a greatest common factor?
No.
Is there a dopes? Is this a dopes situation?
No.
Is this a, let's set aside solving by square roots for the moment. It's not that either. You can't solve this by square roots on both sides. And the problems, let's just talk about it for a moment. If I had this kind of a problem, well, then I can solve that by square roots of both sides. But the problem is I can't pull, in other words, because what I end up with is x, which is what you're trying to solve for. In other words, if I take the square root of both sides, I get x, and the answer is plus or minus 5. But if I had x squared plus x equal 25, I can't take the square root. That doesn't equal anything. So if you have an x squared and an x, either you can apply greatest common factor or you got to do a standard quadratic factoring. And there is no greatest common factor here. So we can't use that technique.
So do we have to use a quadratic formula then?
No, there's easier things to try before the quadratic formula. And one of them is factor it. Factor it into 2 linear terms. Each term is going to be x plus or minus something.
Okay.
Or 2x plus or minus something. So this is where we need the most practice, is factoring stuff.
Okay.
You just cannot get enough practice factoring until you get really good at it. Because if there's one thing they are going to test you on and expect you to be able to do, it's factoring. No matter what level of algebra you're taking, no matter what test you're taking. Factoring is a key skill. So, first step.
Okay, so we have to, I think we can put 2x in the first box there. And then x in the second one in the first place.
That's the first step. Second step.
And then we have 3x.
Hold on. That's not the second step. Second step is to determine the signs. Both
plus or minus.
Well, most times, yeah, they have to be plus and minus. In other words, they have to be opposite. But in this situation, plus minus is not the same as minus plus. It is the same if the coefficients of each x term is the same. In other words, if we had x and x, then plus minus would be exactly the same as minus plus, and you would only have to write it once. But since we have a difference, I'm going to write it that way. In other words, we either have the top case where it's plus minus, or we have the bottom case where it's minus plus. So there are only two choices there. Now what?
So now we have to put the 3 in, which,
No,
or the 3x at least.
the next thing to pay attention to is that number right.
Oh, I remember. I remember. It has to multiply that to equal 20, right? Is that right? I kind of
learn how to verbalize it, because if you learn how to verbalize it, you'll remember it. It's factors of 20.
Factors of 20. Okay.
Okay? That's what you're looking for. In other words, these two numbers that I'm going to write here have to multiply to 20.
Okay.
Okay, so let's look at.
So I guess the factors of
20. Let's figure them all out. What's the next step?
We have 1 and 20. 2 and 10.
10 and 2. Okay.
And 4 and 5. Yeah.
5 and 4. And that's it. Now, this is a trial and error process. I don't know where to begin. I have to guess. Always guess the two factors that are closest together. And just plug them in and see if you can produce the middle term of plus 3x. That's the name of the game at this point.
Okay.
Okay. So I'm going to start off with 5 there and 4 there. Now, does that produce the correct middle term?
Well, don't you have to even get distributed out to check?
The middle term comes from the inside and the outside multiplied together and added.
Okay. So if we go from the middle first, we have 5 in x. So we have 5x.
Okay.
And then we have 2 and 4.
Probably useful to put the plus sign there.
Yeah, plus.
This is. You could ignore it, but when you're staring at a plus and if the other one's a minus, it's a little easier to do the math. What's the outside?
We have negative 2x.
No. The outside is 2x times negative 4.
Oh, okay. 2x times negative 4.
In other words, when you FOIL these two together, that's the O and the I of FOIL. The outside is the two outside terms multiplied together, and the inside is the two inside terms multiplied together.
All right, so that's negative 8x then.
Okay. Add them together, what do you get?
Well, we get you get negative 3x.
Now, is that correct?
No, because the middle one's positive.
Right, but it's the right number. That means our correct.
So that just means we have to switch the variables.
Well, no, be careful here. There's a difference between switching these two and moving them down to the other side. In other words, what you have to switch is the sign on the variable. You don't want to switch places with the 5 and the 4. You just want to put the 4 with the plus sign, because there is a difference. If I switch the 5 and the 4, I get a whole different answer. But because I got the correct number, wrong sign, so all I got to do is move them down. Now that's going to be minus 5x, that's going to be plus 8x, and that will produce plus 3x. It always produces the same number, opposite sign, when you merely move the two factors down from the top row to the next row.
I got that.
Okay. What would be the next step? We don't have to necessarily take it to this final number, but what's the next equations I'm going to write?
We'd have to set it all equal to 0. So we have 2x minus 5 equals 0 and x plus 4 equals 0.
Okay. And again, let's stop there. I'll let you finish that on your own. That's not the stuff we want to be covering.
Okay, so the next problem we have is negative 2x squared. Negative 2x squared plus 5x.
Plus what?
Minus 1 equals 0.
plus
5x.
5x.
Mm-hmm.
Is this greatest common factor? Can I do that?
Could you with the 1, the negative 1?
No. When
Oh,
they
no.
say greatest
No.
common factor, 1 doesn't count.
Okay, well then, yeah, we could do greatest common factor with this.
No, you can't. There's no greatest.
No, I can't?
No, there's no number
Oh,
you can
okay.
simplify everything.
Oh, that's right.
I could
Never
take
mind.
a negative
Just kidding.
1 out. I mean, but that doesn't accomplish anything.
Okay.
When you're looking to see whether it's greatest common factor or not, it means can you pull a number other than 1 out? That's what it means. Other than 1.
Okay.
In other words, x would count, but you can't pull x out.
Yeah.
2 would count, but you can't pull 2 out because 5's not divisible by 2, nor is 1.
Yeah.
Evenly divisible. So, is it dopes?
I don't think so.
It's never going to be dopes if there's an x term. It's only going to be dopes if there's like 2 terms, like x squared minus 4. Going to be that term, they're going to be subtracting, and there's going to be another number there. The only question you have to determine whether dopes applies is the square root of that a clean number, like x, not, 1/3 square root of x, and is that a perfect square number, 4? In other words, if that's 3, dopes doesn't apply.
Alrighty.
Okay? Okay, so this is not GCF, it's not dopes, it's
just another quadratic, isn't it?
quadratic in fairly standard format. Are we going to be able to factor this?
Well, the 1 doesn't really have any other factors.
Well, here's the question you have to ask yourself. Is there any way I can get that as a middle term? Well, the best I can possibly do, even if it was plus plus, and it isn't even that, it's minus plus, but the best I could possibly do would be 1 times 2 and 1 times 1. That does not add to 5. So I can spot immediately that I'm not going to be able to factor this.
Okay.
So the final step is use the quadratic formula. Can't use it if you don't have it memorized. What is it? It always starts with x on the left because that's whatever we're going to write is going to equal.
Okay. So should I just plug it in, or should I say the quadratic formula first?
I'd like you to say it, but not if you're reading it. If you're reading it off a piece of paper, well then just plug it in. But if you're trying to memorize it and you have that paper turned over so you're not looking at it, that's what I'd like to see.
So we have negative.
That's the way to memorize stuff, not by having it on a piece of paper and reading it every time you have to access it.
Okay.
Okay? So what's the general? From memory.
We have x equals negative b plus or minus the square root of b squared minus 4ac over it's 2-something, 2a.
2a, good. Even if you'd have made a mistake, you learned a lot by trying it once. Next time you try it, you won't make any mistakes, and the third time you'll have it memorized and you'll have it in memory. Whereas if you constantly refer to it from a sheet of paper, guess what? You don't ever memorize it. It doesn't sink in by osmosis. It just doesn't. Okay? Now, not a bad idea here to figure out what A, B, and C is, because once you define A, B, and C, then it truly is just plug it in and simplify, as opposed to doing it on the fly. Doing it on the fly, you'd figure out what minus B was first, and you'd figure it out as you went along. I kind of like this method over here. Harder to make mistakes. So what's A?
A is negative 2.
B.
B is 5.
And what's C?
-1.
Okay. Now plug everything in.
So we have -5 plus or minus the square root of 5 squared to minus 4 -2 times -1 over 2 -2.
Okay, that is a good way to do it every time. Don't try to solve any of these on the fly. That just results in lots of mistakes. Now, the next place to go is inside the radical. Let's figure out what that number is.
Okay.
Harder than you think, because notice we're looking at 3 negative signs. Well, that first one means subtraction, that second one means a -2, and that third one means a -2. So you got to be very careful not to make a mistake here, and look, it looks like subtraction is happening 3 times, but it's not. These 3 are being multiplied. So what I always suggest people do is do that as your very next step.
Alrighty.
So what is that number? Not 4, but that right there. Do that as your next step. And I'll tell you why. It can get confusing if you do it -4 times each of those. Because what we're going to do is come up with a number, and then we're going to subtract that from 25.
I gotcha. So we just have -8.
It's not -8.
It's not. It's +8 then, yeah.
Yeah, when you have a minus times a minus, that becomes a plus.
Yeah.
Okay? So now what we have under the radical sign is 5 squared. We'll go ahead and simplify that. Minus a +8. Okay?
Okay.
And by doing it this way, I absolutely minimize the chances of a mistake. Now, we still have our -5 plus or minus that, and that becomes 17. So let's replace that with 17.
-5x plus or minus square root of 17 over -4.
And since I can't simplify square root of 17, that's my final answer. I also can't divide top and bottom by any number to simplify this fraction. You know, in other words, if this was a 6 and there was a 2 in front of the radical sign and I had a 2 in the bottom, well, then I could divide top and bottom by 2 and simplify it further. But at this point, there's our answer.
Okay. So the next one we have is 3x squared minus 2x minus 1 equals 0.
3x squared minus 2x minus 1 equals 0. Now, GCF?
No.
Dopes?
What do you mean by that? Like, is it, because it can't work, can it?
Is it difference of perfect squares?
It's different? No.
No, it's not. Remember, for difference of perfect squares, you usually only have 2 terms, and there's no x term. So if there's a moment you see an x term, it's never difference of perfect squares. Okay? Is it quadratic? Can you factor it normally with a quadratic?
No.
Now, why do you say...
Wait, actually, yeah.
Yeah.
I think we can.
At least there's a ballpark chance that we can, because one of the factors is going to have 1 multiplied by 3. Well, that gets us up to 3, and they're going to be opposite signs, so the other one is going to subtract 1 from that. We're going to end up at 2. So it does look like it factors, and it's always worth doing it this way because this is the least amount of work compared to plugging it into the quadratic formula.
Okay.
So factor.
We have 3x plus or minus, and then we have the other one just minus or plus. And then we have x in the second one. And we have negative 2x in the next slot of the first one. Or just 2x, I should say.
Hold on.
And then we have
Hold on.
1.
Hold
Yeah.
on. You're losing me. I'm not sure what step you're on. First step was to
Okay.
put up the x's. Second step was to determine both sides. What is the third step?
Okay, we have to figure out what the middle term is.
You need to figure out
Like what variables equal the middle
that
term.
number. That's the third step. It's to figure out factors of that number.
Okay.
So what are?
Which is just 1.
Okay. So there's only one set of factors. 1 times 1. 1 and 1. Okay, so that doesn't give us very many choices. And start arbitrarily. Arbitrary would probably be plugging in 1 there and 1 there.
Yeah.
Now, does that answer produce a middle term of minus 2x?
No.
Yes, it does. How do you get the middle?
It does.
How do you get the middle term?
Well, they multiply, and if you add the middle parts, right?
And the eye of FOIL.
The only I of foil, so we have.
Term. I call it my double smiley faces. I don't know. I'd have an easier time remembering it as double smiley faces. But it is the O and the I of FOIL. The inside smiley face is the inside two terms multiplied together. The outside is the outside terms. And, okay, so what's the inside term?
So we have plus 1x minus 3x. And then we get 2x.
We get minus 2x.
Yeah, minus 2x. And then we just plug it, make them both equal to 0.
That means we got it. In other words, that is our solution. That times that equals that quadratic. And then you're correct. You set both of these quantities equal to 0 and solve. But the key is getting the middle term. Notice that every single time we do this, I do the double smiley faces. Because that's the term you have to check. That's the term everybody gets wrong when they're randomly doing it. All right, what's the next one?
Yeah.
What's the next one we got?
So the next one we're shifting into is y. It's y. I think it's it's y equals x squared minus 2x minus 3.
Okay, that's one we just back, right? No,
I think so. No, this is a different one.
3x minus 1. Switch the 3 and the 1s. Nonetheless, it still is going to factor. Okay, and they want you to do what here?
They want us to find the y-intercept, x-intercept, and the vertex and graph it. So y-intercept is just 0.
Now, what is true about the y-intercept? What is true about x?
Is it equals 0 when it's a y-intercept?
Yeah. In other words, if I'm on the y-intercept, it doesn't matter where I'm at on it. The x value is 0.
Okay.
Okay. So the y-intercept's the easiest of all to figure out. It's just whatever that number is every time. Because when you plug in 0 for x, it causes that term to go away and that term to go away. Those first two terms.
Yeah.
I keep pointing with my cursor, and I remember you can't see where my cursor is pointing. It's an unfortunate aspect of this. Because I can point with the mouse. If I point with my mouse, you see where I'm pointing. Okay, so the y-intercept is negative 3.
The y-intercept is negative 3.
Yeah, it's always that number.
Okay.
Now, the x-intercept. What's true when I'm on the x-axis? Wherever I might be, what is true about y?
It equals, wait, it equals 0 too, right? Because you're on the x-intercept, or x-axis.
So when I'm solving for the x-intercept, I want to make y equal to 0, not x.
Okay.
Now I'm solving that equation. How do I solve that equation?
So then we factor it, right? Or not factor.
No.
Yeah, we can factor it.
Well, you go through your list of 5 priorities. Can you do greatest common factor? No. Can you do dopes?
No.
Got to do it using quadratic factoring or the quadratic formula.
Okay.
So which one?
I think we can try to factor it at least.
Always try factoring, because if it factors, it's a lot easier than going through that whole quadratic formula.
So then we get x in both of the fronts of the parentheses.
Okay, that's step 1.
Yeah, and now we have to find the factors of 3.
Nope, that's not step 2. Everybody wants to skip step 2.
Oh, it's plus or minus,
yeah,
and then minus or plus.
Okay, they must not teach this in school this way, where that's step 2. I must be the only one that does that. Because
no, I always learn to do that like last.
Well, a lot of people get taught the diamond method. A lot of people get the California method. I think both of those are extremely confusing, and this 3-step method is flawless on most quadratics that you're going to have to factor. Now, granted, when it's a more complex quadratic, it's a little tougher, but that you're going to do 10% of those. 90% of the ones you're going to have to do in life are going to be these easy ones. So let's learn the easy method. Now,
all right,
you're looking for factors of 3 that do what?
Equal -2.
Nope. Start from right and move left. You're looking for factors of 3 that subtract, because of that negative sign, to the number 2. Not to -2, but to the number 2.
Okay.
So that's the 3rd step, is start from the far right and work your way left. Factors of 3. Let's talk about factors of 3. That's it.
Yeah.
One goes with the positive sign, one goes with the negative sign. Which?
The negative sign would be a 1.
Nope.
Right? Or no, the negative sign would be a 3.
The rule is you take the bigger of the 2 factors, which is 3, and you put it with the sign of the middle term, which is negative. So the first thing I do is put the bigger factor with that negative sign. Only other place to put the 1 is there. And that is the correct factoring of that quadratic. So where are my x-intercepts? In other words, I've got a parabola that does something like that. What are both of these values?
Are they equal to 0, right?
Yeah, if that's what you meant.
Okay. Would we put each one equal to 0 though?
Correct. Just tell you what, whatever process you know at this point, tell me what these values are. You should know enough at this point to be able to give me 2 numbers.
We have 1 and -3.
Nope.
Alrighty.
But you're close.
Okay. Would we have -1 and +3?
Yeah. Because the answer is, you said each one of them equal to 0. Which gives you -1 is one answer. And when I set x minus 3 equal to 0, I get +3. So these three values, that point is 3, 0, and this point over here is -1, 0. Those are your X-intercepts. And we can write them up here as just -1, 3. That's both of them. Okay? Now let's talk about the vertex. What is the easy way? Let me rewrite it. It was x squared minus 2x minus 3. That was y. What's the formula for the vertex? How do I find the vertex?
X equals -b over 2a.
Yeah, I don't know that I would call it x. It's not x equal. It's the x-coordinate of the vertex is what's equal to -b over 2a.
Okay.
I guess you could say x. I guess that wouldn't be totally wrong way of looking at it. It is the x-coordinate of the vertex. I prefer writing it like this so I know exactly what it is, because we're also going to have to figure out the y-coordinate of the vertex. So what's the x-coordinate?
The x-coordinate.
In this case, with this function.
Would it be -1? Is that just plugged in from the top, or is it still like the intercept one or not?
Plug in for every letter you see here. What's -b?
-b is -2, so that makes it +2.
What's 2a?
2a, so then we get 2 times 1, which is just 2.
That's the x-coordinate of the vertex.
Okay.
Now what's the y-coordinate of the vertex? Because you won't know how to plot it unless you know both points.
Okay.
How do you get it? Once you know the x-coordinate, how do you get the y-coordinate?
Hold on. Just a second. Wait, do you substitute the result of that equation for the original equation?
Exactly.
So we just substitute 1 in for y in the first equation?
Not for
equation.
y. For x.
Not for y, but for
that
x.
Is
then?
the x-coordinate right there. 1 is. That's where the vertex is going to happen. It's when x equals 1. Okay? The question is, where is y when x is equal to 1?
It's in the front of the equation still. No.
Tell me what to fill in.
Guess we have y equals 1 squared.
Yeah, and I'm going to put parentheses around it just to good habit, even when the number is 1.
Okay, -2.
If the number were -1 or minus anything else, you would have to have the parentheses. So now simplify that.
So we get 1 minus 2 minus 3.
Is that equal to?
And then we just get -5 and 4. So just be -4.
So that's the y-coordinate. That answers part C. The last thing is to graph it. Where do we start?
We take the x and the y vertex and put them together.
Okay. Now let's graph that point. So what's the point that we're graphing?
1, -4.
Okay, that's right here. We'll call that 1, -4. In other words, I don't need a grid. I just need it to be spatially proper. In other words, that should be about 1/4 of that distance. And that's why I put it way down here. Now, what else do we know? We need 3 points to graph this parabola. First of all, does it open up or down? Does it open up or down?
It would open up, wouldn't it?
Okay, yeah, because the coefficient of the x squared is positive.
Okay, so then when we take
what other 2 points can I use?
we could take the other x points we had from the first part of the equation.
Well, the x-intercepts.
Intercepts, that's what I meant.
Okay, what are they?
And then we have -1, 0.
Okay, so -1 is right there, not 0. The other one was 3.
Oh, yeah. And then it's just 3.
So those are our x-intercepts. Notice we now have 3 points. We can draw a perfect parabola. I knew how to draw. But 3 points define a parabola. Okay, and you probably label all 3 points. So what does that point label, and what does that point label?
-1, 0. And 3, 0.
You've answered every part of their question.
Okay.
Okay.
Cool. And then, yeah, let me look at what else we got going here. The next one being, okay, yeah, we have y equals 1/2 x squared plus 4x minus 10. And we have to find the focal point, graph, I think the vertex, and the y directrix. So we have an equation here that is
yeah, this is a whole different type quadratic. It looks exactly.
This is a parabola, isn't it?
They're all parabolas. But
yeah.
Now there's something else that we want to pay attention to, which is where is the focal point? In other words, all parabolas have a focal point. If I draw a parabola there, there's a focal point somewhere around there. If I draw a parabola like that, there's a focal point somewhere. And wherever your focal point is, your directrix is perpendicular to the line of symmetry and an equal distance from the vertex as your focal point. So the directrix is really pretty easy once you find your focal point.
Okay.
Now, how do you get your focal point? Well, first of all, we need to put this in the format of this type parabola. When we're trying to find focal points, the formula is different. They don't use the vertex format. They use something close to it. Here's the vertex format for a parabola.
All right.
Notice if I subtract, and if I tell you that A equals 1 over 4p, which is a true statement, p being the focal length, p being this distance right there. That's p. Okay?
Okay.
Now, if I give you this, well, let's transform this equation a little bit. Let's take the k, put it on the other side. So we end up with y minus k equals a times x minus h squared. And now if I substitute that 1 over 4p for a and multiply both sides of the equation by 4p, this is what I get. And you don't need to memorize the process we just went through. The only reason I did is to show you that it's the same, it's very similar.
Hold on one second.
Format.
Do you think you could take 2 minutes if you can turn it?
I mean,
Stronger hands?
yeah. Okay, just a minute. Sorry, I was interrupted.
No problem. Okay.
All right, let me.
There's no easy way to figure out focal point. There's no minus b over 2a kind of thing. So
Okay.
you really only have two choices. You can transform that into the vertex format. You got to complete the square also to do it. Or you can transform it into this format. And you also got to complete the square to do that. So if they teach you the 4P format, then that's what we should use.
Okay.
If they teach this format, that's what we should use. It depends on your school system. Different school systems teach it different ways.
Okay, I think we used a 4P one.
Okay, let's do that format then. Okay, so go through that process. There's my format at the top. We'll call this, it's not vertex format, we'll call it focal format. Never heard anybody call it that before, but I like it because this is the format you use when you're concerned about the focus.
Okay.
Okay. Now, the trick is how do we turn this formula into this format? What would be a good first step?
Well, I would assume you'd plug in, but like...
There's nothing to plug in.
Nothing to plug in?
No, what are you going to plug in? You got to transform.
Yeah.
You got to move this around algebraically so that it looks like this. Well, first...
It looks like the bottom equation, yeah.
First thing I see is I got a y minus k there. Well, what can I do to this formula? So let's try to get that for starters.
Okay.
So what can I do to this equation on the bottom row here to begin to get it into this format?
We'd have to put y on the other side, wouldn't we?
No. It's on the right side. It's on the left side. That's where I want it.
Okay, well that means you'd have to get rid of everything else on that side then.
Not everything, just the 10.
Okay.
So the first thing we're going to do is add the 10, which gives us this. Now,
okay.
Now we got the y minus k part. Okay. Now, whenever you see an x squared and an x, and you know that completing the square is what you have to do, every single time they ask you about focus, you're going to have to complete the square. So know that it is part of the process. And you complete the square with the x squared term and the x term. There's no number over here, which is good. We don't want a number over there. We want to complete the square. Question is, how do I do it?
I'm not really sure, to be honest with you.
Okay. You're going to have to memorize this. There's one thing you got to do in algebra over and over and over again is complete the square. Okay? So, we cannot complete the square until we make this coefficient 1. So,
you cannot complete which coefficient?
The coefficient in front of the x squared term.
Oh, okay.
Cannot complete the square as long as that is a number other than 1. So for me to make that 1 means I got to factor out the 1/2. And what I am left with is that.
Okay.
Now what's important is that you notice that I have not changed it. Everything is the same. I've just rearranged it.
Okay. Where did the 8x come from?
Well, 1/2 times 8x is 4x.
Oh, okay.
So what I really did was I divided both terms by 1/2. When you factor what we're doing is, it's not quite a greatest common factor, it's the greatest common number. And it's not even that. It's not even that. What you have to do is get rid of that 1/2. And the only way to do it is to factor it out. Even if 4 were not divisible by 1/2, I would still do it. You got to get rid of that 1/2. Well, the way you get rid of it is you divide both terms by 1/2. Well, when I divide that by 1/2, flip and multiply, I get 8x. So the way you get these other two terms is to divide both terms. I'm going to divide that term by 1/2. The 1/2's cancel, and I'm left with x squared.
Okay.
Okay. So now I am in a position to complete the square.
Alrighty.
Inside the parentheses, there is nothing but a x squared term with a 1 in front of it and some number of x being added or subtracted to it.
Okay.
What I want this to look like is x minus h quantity squared. And then I'm getting closer and closer to my format. Okay? Well, it doesn't look like that right now. It looks like x squared plus 8x. But I can make it look like this by taking half of the coefficient of x and squaring it and writing it in. What's half of 8 squared?
16.
Okay. Now I'm about to make my first change. Everything else I've done has not changed anything. Just rearranged it. But the moment I write in 16 there, I've added a number to the right side of the equation. What number did I just add to the right side of the equation?
The squared half of 8.
Half of 16. I wrote in 16, but it's being multiplied by this 1/2. So what I really did was I added 8 to the right side. So how can I balance things out so that I'm not changing anything?
Divide.
Add 8 to the left side. You can always do whatever you want to both sides of the equation. Well, I just added 8 to the right side. So I got to add 8 to the left. Now everything is the same. It's no longer different. It's just written differently. But here's the thing. Now I can write this as y plus 18 equals 1/2 times x plus 4 squared. my x minus h squared.
Okay.
Okay? We're getting closer and closer to this format. In this format, you got to memorize it. There's just no way around it.
Yeah, I got you.
And over here, we don't have an a anymore. It's just x minus h squared. Okay?
Okay.
So, we're getting really close to it. We got this 1/2. We got to do something about it. What can I do to get rid of the 1/2?
Multiply by the inverse of it on both sides?
Multiply by
Oh no, is you have a squared.
no,
Never mind, yeah.
1/2 is not being squared. When you have parentheses
No, ignore that.
it only applies to what's inside the parentheses. It
Yeah,
doesn't apply to
no.
numbers in front.
Okay.
Okay?
So back to what I originally said then.
Which is multiply both sides by 2.
Yeah.
Okay, now this is what we're looking at. Don't distribute. Just leave it like that. The reason I don't distribute is now we are exactly in that format. Are we not?
Yeah, that looks like it.
Okay, so tell me what 4p is equal to.
Well, is P 2 then?
No, tell me what 4p is equal to.
Okay.
That's 4p.
Well,
In other words,
it's 2?
4p leads the y minus k, right? It's in front of it. So
Yeah, I understand.
once you get it in this format, then you can say, well, everything else is the same, therefore 4p has to equal 2. Now solve for p.
So, to solve for, well, didn't you say that? Okay.
No, I said 4p was equal to 2.
4P was equal to 2?
4p
So
is
let's
equal
make
to
P
2.
1/2 then.
That's 4p right there. That's 4p, and it's a 2. In other words, whatever the coefficient is in front of the y minus k, there's the y minus k, whatever the coefficient is that's in front of that is equal to 4p, always. If that were a 3, then 4p would be equal to 3. It's a 2, so 4p equals 2. What does that make p equal to?
4P equals 2. Well, then does that just make it... Yeah, what's up? Oh, okay. What was I saying? So I was saying 4P equals 2.
So what's p?
See, I just don't have... I'm just having trouble understanding where, like, it comes from, I guess.
Okay. Where it comes from is we've manipulated this equation so that it looks a little different. It now looks like 2 times y plus 18 equals x plus 4 squared. Well, that's exactly the format we want. There's our y plus 18. There is our x minus h squared. That's x plus 4 squared. And the number that is in front of the y minus k needs to be 4p. So the reason 2 is equal to 4p is because 2 is the number that is in front of the y minus k.
Okay.
And I don't distribute it. It is not 2y plus 36. I want to make sure that that 2 is in front of the entire parentheses, y minus k, because that's what the general format is. It's 4p times y minus k, the quantity, equals the quantity x minus h squared. So we got it into the format, and now it's a simple matter. That's the hard part. The simple part is equating these two coefficients. In other words, I know that this number in front of the y minus k is 4p. That's the format. So I set it equal to 4p, and now I solve for it. Tell me what p is. You're drawing a blank on solving for P. Why?
So you said we don't distribute for Ben, right?
Correct.
Because then it wouldn't...
We're on this
Okay.
step right here. We know 4P equals 2. What's P equal to?
Okay. Just Y plus 18 then? Is that?
I want you to solve the equation that I've circled.
Solve the equation that you should... Okay.
4P equals 2. Keep going. Solve that for P. You haven't
Well,
solved
then
for
wouldn't
P yet. You haven't solved for P yet.
Alright. Well, if 4 times P equals 2, right? Is that how that works? Or?
Very simple equation. Now solve it.
Okay. Well, then P would just be 1/2.
There you go. That's all I wanted.
Oh, I said that.
To be drawing a blank on it. It's not 18. It's just this equation you need to solve.
Yeah.
Forget everything
Okay.
else. Forget everything else. Once you get it down to that equation, now it's one very simple step to come up with what P is. P is 1/2.
I guess I got confused because I said 1/2 P is my original thing. You said it was wrong. That's probably why.
Oh, I never heard the 1/2. I heard 2.
Oh, see, that's probably why.
Yeah, sorry, my fault.
No, it's no big deal. It was.
So, if when you're talking, have you had the horizontal parabolas yet?
I don't think so.
If you're studying conic sections, you probably have.
Okay.
In other words, back in Algebra 2, all parabolas either pointed up or pointed down. Those parabolas are of the form y equal x squared. But when you start studying conic sections, you also have parabolas that can be horizontal. They can be like that. Or they can go the other way, like that. They're still parabolas, they're just horizontal instead of vertical. These are of the form x equal y squared, not y equal x squared.
Okay.
To keep them straight, I would say always remember what the original parent function for a parabola is. It's y equal x squared. And those are the vertical ones. Well, if these are the vertical ones, then I got to switch my variables to get the horizontal ones. So the horizontal one is always x equal y squared. Now, the formats are different. I'm going to write the formats down below. The official format that allows you to solve for the focus. And we'll talk about the differences. The 4p always goes in front of the variable that is not being squared. In this case, it's the x, if we're dealing with this situation here. So it's x minus h. H always goes with x, always being subtracted from it. On the right side, it is now y minus k that's being squared. That's it. That's the format for those horizontal parabolas.
Okay.
The format for the vertical parabolas, we just did a problem. And it's the y minus k that is not being squared, but it's the x variable that is being squared. Those are vertical parabolas. Notice the two differences between these two formulas. And notice the same thing. It's the same thing about them that you want to memorize. And that is, which side does the 4p go on? And where does it go? Well, it always goes in front of the variable that is not being squared. It doesn't go in front of the variable being squared. So it doesn't go over here on the right. You have got to memorize both of these, because I would find it very difficult to believe that you're into conic sections and they are not giving you horizontal parabolas also.
Yeah.
In other words, if I give you this equation, that is x is not being squared, but y is. That's a horizontal parabola.
Okay.
Okay? Everything's the same. You do every single thing we did the same to get it, but into that format, not the one over here on the right.
Okay.
Until you master the vertical ones, probably we should stick with those. The only reason I bring this up is because I'll bet you get some of these horizontal ones. And the way you recognize them is it's x equal y squared instead of y equal x squared.
Alrighty.
I have another one of these that involve, oh, we're not done yet. Hold on.
Alrighty.
Our original was y equals, oh God, 1/2 x squared plus 4x minus 10, right?
Mm-hmm.
Okay. There it disappeared again. How weird. Bizarre. I wasn't touching the tablet or nothing.
Wonder why it's doing that.
Oh no. At least it doesn't lose my writing. It takes me back to the same spot.
Lucky that. If it got rid of it, that'd be
Yeah, that'd be a... No, I did lose my writing. I had already written out the whole thing. It's x squared plus 4x minus 10. That's the function that we're graphing.
Okay.
Now, immediately we can see it's y equal x squared, so it's a vertical parabola.
Yes.
And we just have to figure out where to graph it. In other words, we know where the focus point is, but we still don't know how to graph the parabola. So how do I graph this parabola?
Well, it would be going, because it's vertical, right? It'd be opening up to
Actually,
the opening.
now let's go back a moment. What we turned this into was 4p times y minus k.
Yeah.
Yeah, I forgot. The h and the k here are still the vertex. We do not have to go back and recalculate the vertex. This was x plus 4 squared, I believe. Yeah.
Yeah.
P was 1/2, so we had 4 times 1/2 times y plus 10 equals x plus 4 squared. So when we were all done with turning it into this format so we could figure out what P was, we actually are still in vertex format, believe it or not. Where's my vertex? Oh, still h and k. That's still h and that's still k. So where's the vertex?
Doesn't the vertex fall between those two, right?
Minus h. No.
Minus h?
This is not X-intercept format. This is vertex format. The vertex is h comma k.
H comma k.
H and k are always the vertex. When it's
we'd
vertex form, or if it's in this is merely an alteration of vertex form. This is still very much like vertex form. To the extent h and k are still the vertex. So what are h and k?
4 and 10.
It's x minus h and it's y minus k. What is h and k?
Would we have 4 and 10 in a...
Well, let's see if that works. If I substitute 4 for h, I get x minus 4. And if I substitute 10 for k, I get y minus 10. Is that what we're looking at?
That seems a little extreme.
Well, that means h and k are not 4 and 10. In other words,
Okay.
you got to get back to these two things here. Whatever you put in for h and k, it better result in x plus 4 and y plus 10.
Okay.
So tell me what h and k are.
So they have to result in positives, right?
Yes. So what is h?
Okay. Well, if it results in, would it just be a, does it have to be like, I don't know, I'm just trying to find a way to make it like positive. Would it be like a negative? Would it be minus negative like 1 or something?
I'd have two negatives together, it would turn positive. So how about an h
Okay,
of
so
minus 4?
an h minus 4?
Yeah. In other words, if I plug minus 4 in for h, I end up with x minus a minus 4, which turns into what I've got, x plus 4. So h
Okay.
minus 4.
Yeah, already.
K have to be.
So k would also have to be a negative, so it'd be y minus negative 10.
K is negative 10.
K is negative 10, yeah, but it's like to get the
Now
next
there's
part.
the vertex. Minus 4, minus 10.
Okay.
Okay? Now, looking at the original function, does that open up or down?
Up, right?
So I know I'm going to have a parabola that opens up from that vertex, but I got to find two other points because I need 3 points to plot a parabola.
Okay. So I feel like the next point would be 10.
Hold on a second. Did I make
Okay.
a mistake here? Something's wrong here. The reason it is because my y-intercept should be minus 10. My y-intercept is minus 10. It cannot be my vertex unless I'm on the y-axis, and I'm not on the y-axis because my h is minus 4. So let me think about this for a second. Make sure that, let's see, if I complete the square, let me just do this again real quickly. I'm now a little puzzled as to, in other words, follow me though. Going from there to there.
Okay.
Okay, I didn't do anything. I didn't change it. I'm going to leave the 10 over there for a moment. In other words, I'm going to put this in pure vertex format. Vertex format is a times x minus h quantity squared plus k. That's vertex format. And then h and k are the vertex. So the first step I did, factored out the 1/2. Second step, I'm going to complete the square. And what I did was I just added 8 to both sides. Okay. So I got to subtract 8 from this side. In other words, when I'm working on the same side of the equation, when I add a number, I got to subtract it to balance it. If I'm working on the other side of the equation, I need to add it. But in this case, I added 8 when I wrote in that 16, and therefore I need to subtract 8. And now we do get something different. It gives us a different vertex. That is something that I didn't realize until just now. And our vertex is at 4, 2. Minus 4, 2. Not minus 4, 10.
Okay.
I see why. No, I don't. Hold on. What's going on here? Ah, I see what's going on. Huh. I didn't do it right the first time. Interesting. In other words, when I put this thing in vertex format, it comes out to that, the bottom right equation. That tells me my h is minus 4 and my k is plus 2. So my vertex is actually right there. Minus 4 plus 2. Now, what happened? What did I do wrong when I tried to put it into this 4p format? And I'll tell you exactly. You've got to complete the square before you move that number over.
Okay.
In other words, my first step should not have been to move the 10 over. My first step should have been putting it in vertex format like this. Then you get the proper vertex, and now I move it over. In other words, I'm still going to move it over, but if I move it over at this point, it makes a difference. In other words, now I get y minus 2 equals 1/2 x plus 4 squared. And now I multiply both sides by 2, and I get this. And now I can figure out p, because I know that this 2 has to be 4p. And so p comes out to be 1/2 still, but you got to be very careful with this vertex. If you move that 10 over first, you get the wrong number. Which is a little puzzling to me as to how it can possibly be different. But I'm going to have to think about that, and maybe I'll tell you about it next time. But regardless, it does matter on this problem. In other words, our vertex is at 4, 2.
Okay.
Okay. And we know one other point was a y intercept of minus 10. I've done something here to mix these numbers up. I'm not quite sure what. What did I do? What could I have done? There's no way this, with that vertex, is that the right vertex? Minus b all over 2a. That's minus 2. How am I getting plus 2? Ah, I see. Because it was minus 10 that I turned into plus 10. And then I have to subtract 8 from minus 10, which gives me minus 18. And I have no idea what's going on right now, Mary. We can address the problem another time. We need to go over more of these, because the only way you're going to get them is with repeat.
Yeah, okay.
I don't know where I went wrong here. I went somewhere drastically wrong, and I used a minus sign instead of a plus sign, and we don't really have enough time now to go back and figure out where I went wrong. So let me suggest we end and pick up with this one next time. I assure you we'll get it right next time.
Okay.
I'll figure out what I am doing wrong.
Alrighty then.
All right? Okay. I will talk to you next time.
Okay, bye-bye.